Our next problem is to write the Lewis structure for each molecule. Molecules contain covalent bonds, meaning the valence electrons are shared rather than donated, like in ionic compounds with ionic bonds, which donates electrons. So our first example is pH3. Now each hydrogen is going to have one valence electron, and phosphorus has 5 valence electrons. So there's 3 hydrogens around 1 phosphorus. So we're going to put our phosphorus in the middle and a hydrogen on the left, on the right, and on the bottom. Okay, so hydrogen has 2 valence electrons. In order to make it a duet, to make it happy. So we have single bond here. So all the hydrogens are complete. They are duet, they are happy, they're full. Now phosphorus is not. It only has 6 valence electrons right now, but it needs 8 in order to be full and happy. So we just need to add 2 more electrons on the top. Our next problem is sulfur dichloride. So sulfur is going to have 6 valence electrons, and chlorine has 7 valence electrons. So since there's 2 chlorines, we're going to put our sulfur in the middle and the chlorines on either side. So we have our sulfur, and then a chlorine on right and a chlorine on the left. Now we're going to attach these with a single bond for now. So now we have 4 electrons around the sulfur, so we need to add 4 more in order to make it an octet. So we have 1, 2, 3, 4. And then chlorine, we also need to add more valence electrons in order to make an octet. So right now we have 2 valence electrons, so we need to add 6 more. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Our next problem is F2. This is a diatomic molecule. So fluorine has 7 valence electrons, and since there's 2 of them, we're just going to write them right next to each other. So right now, each fluorine only has 2 valence electrons, so we need to add 6 more. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Our next problem is hydroiodic acid. So hydrogen again only needs 2 valence electrons to be happy, and iodine needs 8, but it already has 7. So we have our hydrogen bonded to our iodine. And then we need to add our electrons and our iodine to make it full and happy. Now when looking at this entire problem here, let's relook at hydroiodic acid. So hydrogen normally only has 1 valence electron, and iodine normally only has 7. However, when they share a pair of electrons, it creates a duet for the hydrogen and an octet for the iodine. And that is true for the rest of the example.